In this video, I'm going to start you off with some challenge questions to pick up where we left off with the titration of phosphoric acid on the previous video. Here is what I'd like you to consider with this titration. First of all, what's the buffering range for this system? Maybe put the buffering range on this curve. Second of all, where is the blood pH of 7.4 on this curve? And is this curve in the buffering range appropriately to be a buffer for pH 7.4? And here's the tricky ones. What two species, A, B, C, or D, are in blood? Okay, let's pause for a moment and have you answer those questions. Do them all, then turn it back on, and we'll see how you did. Okay, remember, buffering range is always plus or minus 1 pH unit above the pKa. So, here's the interesting thing. There's a buffering range right here for that pKa. There's another buffering range right here for that pKa. And then there's another buffering range up here. There's actually 3 buffering ranges. One for each pKa, one for each proton that is removed. Now you got to understand something. The range is in here and here and here. When we're in between these ranges, there's not good buffering. And you can see that visually because the lines are not flat. We're not keeping the pH constant here. So in a triprotic system, we only have buffering in this area, 1 pH above and below each pKa. Second of all, where is blood? Let me use a different color here so we can see it very carefully. Blood is at 7.4, and that's going to be right there. Let's go ahead and put a blood label right there. And let's ask the question, is this system a good system for buffering blood? Well, clearly it's in the range, and that's a good thing. Now here's a tough question. What 2 species are in the blood? And I might add this. Are they equal in concentration, or is one more prevalent than the other? Now the answer is as follows. As we go through this titration, we start on the left. We have a 100% A. We convert to 100% B. We go through blood on our way to C, and then later all the way to D. So in blood, at 7.4, we have a combination of B and C, because that's what we are titrating at that point. We're converting monobasic to dibasic. So the answer to that question is B and C. Now, can you figure out which one there is more of, or are they equal? To be equal, we'd have to be right in the middle. We'd have to be at the pH is equal to 7.2. That would be 50-50 by definition. However, we're a little past that. We're at 7.4. That means we've converted a little more than 50% of B to C, and therefore we have more of C. Could we figure out how much more? Well, that's coming next, but let's just put the quantitation aside for a moment. One last question. Does phosphate buffer blood? The answer is, oddly enough, no. It looks, let's go to the bottom of the page. It looks pretty good on the buffering range. At least that middle range is 7.2 plus or minus 1. That equals 6.2 to 8.2, and that seems to work. 7.4 is nicely in the middle. However, what's the problem? It's the buffering capacity. The buffering capacity is kind of like a sponge. Think of a buffer like a sponge. A sponge's job is to soak up water, and a buffer's job is to soak up protons. The bigger the sponge, the more water we can soak up. The bigger or the more concentration of buffer we have, the better the capacity. And buffering capacity is proportional to concentration of the weak acid and its base. We have the weak acid and its base, and it's the appropriate pKa for the buffering range, but there is too little, only 0.5 millimolar in your blood. There's lots in your body, just not much in your blood. And this 0.5 millimolar, it's just not enough to neutralize a lot of acid or base. So it would be overwhelmed, just like a sponge, a small sponge would be overwhelmed by a lot of water. Okay, so in our hunt for a buffer for blood, we said it's not acetic acid, wrong pKa. It's not phosphate, too little buffering capacity. So what is it? Well, we have to go back to our chart and see what we see. We said it was not heaps. Now we've said it's not monobasic phosphate. Usually we can get people to try the very last possible choice, and that's carbonic acid. 6.3 seems like it's a little bit outside the pKa buffering range, and that's true, it is. But let's go see in the next video the titration of carbonic acid and see why it's a unique example of a buffer and why it's so good at doing its job in our blood.